Acid-catalyzed hydration of an alkene. You are adding an H2O equivalent across a double bond. So if we have a generic alkene, going to make it asymmetrical with one that's more substituted than the other. That is going to be the nucleophile in the reaction. The electrophile is going to be your acid catalyst. In this case, it's going to be sulfuric acid. And then it's going to be aqueous, so there'll also be water present as well. The first step is for the pi electrons in the alkene. Oops. Pi electrons in the alkene, flick out, grab the proton, that breaks this OH bond, puts the electrons onto the sulfur. Now your intermediate here, HSO4 minus, is going to depend on the stability of the carbocation. So these two electrons can make a CH bond either on this carbon or on this carbon. If we make it on this carbon, you'll have a secondary carbocation here, but if you put it onto this carbon, you'll have your tertiary carbocation here. So this is the more stable carbocation, so it's going to be the intermediate. At this point, this is where your water comes in. We're going to draw an arrow from the far side of the page here. Zoops into there, giving you your next intermediate. OH2 plus. OH2 plus is a really good leaving group, and this reaction is reversible because the sulfuric acid could come down, grab the H, bring it back down, and do the elimination like that. So it is a reversible reaction, but it will depend on the concentration of each reagent. But what could also happen is that this HSO4 minus can come and grab a proton, put the electrons back on there, and give you your final product of a alcohol. So what you did here, you started off with an alkene. You use sulfuric acid to add a proton across the double bond. Water comes in as your nucleophile, hits your most stable carbocation. Your HSO4 minus deprotonates the OH2 plus. This generates your alcohol final product and also regenerates your acid. That's what makes it a catalyst. So the acid is used and regenerated. That's what defines catalyst. So you're going to be using H2SO4 and water, or you can see it as aqueous, with a double bond to make the most substituted alcohol. That's one reaction.